Hello, chemistry students. This is a little lecture on bonding and polarity. So what we're going to talk about first is a little bit of an introduction, and we're going to talk about something called electron dot structures. Now, this should sound familiar to you because we did draw electron dot structures for atoms. We've drawn them for ionic compounds, and now we're going to learn how to draw them for molecular compounds in order to show that electrons are shared in order to form covalent bonds, which then form the molecular compounds themselves. So let's get started. All right, so first we have to talk about what a chemical bond is. Remember that chemical bonds are always created by electrons. The electrons are the particles that are the most interesting in the atom because it's the interaction of these electrons, specifically the valence electrons, that are going to allow atoms to combine in order to form different compounds, all the compounds that we see and use in our lives every single day. So bonds are typically formed by sharing or by transferring electrons. Ionic bonds specifically are going to be formed when electrons are transferred from the metal to the non-metal. And so this is kind of like bringing some old clothes to Goodwill. So when you bring them to Goodwill, you transfer your clothes to Goodwill. Like you don't expect them to give them back to you. They're there for good. And that's exactly what's happening in the transfer of electrons from a metal to a non-metal. The metal is giving its electron over to the non-metal. And so my next question is, what happens when sodium and chloride join together? So this is just a little bit of review. Go ahead and pause the video and on a scratch piece of paper, see if you can draw what happens when sodium and chloride form an ionic bond. And while you're at it, you may as well grab your chem helper too. All right, so now's your time to self-assess, and here's what is happening when you have sodium transferring its electron to chlorine. So here by the red arrow, you can see that our sodium is transferring its electron over to chlorine, and that's going to give sodium a positive charge, chlorine gets a negative charge, and now they are held together by the electrostatic force, which allows opposite charges to attract and stick together. Covalent bonds are the bonds that form molecular compounds. This is where two non-metal atoms, now remember that's different from an ionic compound. In an ionic compound, you have a metal and a non-metal, but here you have two non-metal atoms and they are going to share electrons in order to achieve a full valence shell. So for instance, in our hydrogen molecule that we have, here you can see that one electron is going to be shared here and another one is going to be shared here. So that would be from, let's just say, our electron here on the left, from our atom there on the left, and then while the one on the other side is going to share these here. So at any rate, they are going to have they're going to have a full valence shell. Now, the thing that you have to notice about this picture is that the clouds are overlapping each other. And so the atoms have to actually get very close together in order for those electrons to be able to be shared. So you've got to have some overlap there. All right. So, what you need to do here is on your scratch piece of paper, you should number the valence electron for the left oxygen in blue, number the valence electrons for the carbon in green, number the valence electrons for the right oxygen in red, and then I'm going to ask you to actually highlight the shared electrons. And then note that the X's that we have in this drawing are going to represent carbons oxygen's original electron. So what's happening here is you've got a carbon atom in the middle, and then you have an oxygen kind of coming in, one from each side, and those energy levels overlap. So now they're able to share electrons. So remember that carbon is in the fourth column on the periodic table. So it needs 4 electrons in order to achieve a full valence shell. Oxygen is in the 6th column, which means it requires 2 electrons to achieve a full valence shell. So let's just take a moment and see if you can follow these directions. All right, so let's see what this looks like for you guys. There we go. So here I've got my valence electrons for the oxygen on the left. They're numbered here in blue. So we have, now remember, like the X's are the ones from the carbon and they're being shared. So they count towards the oxygen on the left. And so that's why I've got the X's numbered here as well. And as you can see, my oxygen on the left has a full shell. It has 8 valence electrons. The X's that are on the right-hand side count not only for my carbon, but also for the oxygen here, because again, it's being shared, so they get to be counted twice. And so here in red, I have all of my valence electrons for oxygen labeled. And then for my carbon, you can see that it has gained 4 electrons, exactly what it needs in order to have a full valence shell. So the dots here, we have, it gained 4. So electron number 2 is the first one, electron 4 is the second, 7 is the third, and 5 is the fourth. And so my carbon has also gained the appropriate amount of electrons in order to have a full valence shell. So the ones that are highlighted in yellow, these are the ones that are being shared. They spend some of their time with their respective oxygen, and they spend some of the time with the carbon. And that's what it means to share. It's kind of splitting their time between the 2 atoms. Okay, so what exactly is a molecule? So this is a vocabulary word that you learned back during the periodic table unit. This is a neutral group of atoms that are covalently bonded together, which means that these atoms are going to share electrons with each other. And so sometimes molecules can be made of 2 atoms of the same element. For instance, hydrogen, elemental hydrogen or pure hydrogen, which is H2, that's a molecule. But sometimes they can also have different elements. For instance, a carbon dioxide molecule is made up of 2 different elements, carbon and oxygen. But at any rate, the electrons are shared. Here in the picture, you can see that water, H2O, is also a molecular compound. It has covalent bonds. We have the sharing of electrons that that's happening between this hydrogen and the oxygen, and then you have sharing between the second hydrogen up at the top and the oxygen off to the side. So electrons are shared in order to form covalent bonds. And a group of atoms that is covalently bonded together is called a molecule. Okay, so we're going to show the sharing of electrons using electron dot structures, or EDSs. So remember that atoms need to share electrons in order to achieve a full valence shell. And for most atoms, this means that they want 8 electrons in that valence shell. But there's a couple of terms that you need to know. So if you look at this electron dot structure for chlorine, you know chlorine has 7 valence electrons. So those are the 7 dots that are around my chlorine abbreviation. When you have 2 dots that are right next to each other, as you can see in the red circle, these are called lone pairs or unshared pairs of electrons. These are the electrons that just stay around the chlorine. They are not going to be shared out with any other element. The one that's circled in yellow is called the unpaired electron. This is the one that's going to be shared in order to form covalent bonds. Now, since chlorine has only 1 unpaired electron, that means that every chlorine atom can only form 1 covalent bond. we are going to represent that covalent bond with a bond line. So if you take a look at our electron dot structure, all the way over here, you can see that we have chlorine here has its 7 valence electrons, and hydrogen here has its 1 valence electron. And so what's going to happen is that chlorine is going to share its unpaired electron with hydrogen, and hydrogen is going to share its unpaired electron with chlorine. And what happens is we're going to have a bond line here that represents the sharing of those 2 electrons. Notice that chlorine keeps its valence electron dots. We're not going to throw those away. We need to keep those there. And hydrogen doesn't have any other dots besides the dot that's being shared with chlorine, so it's not going to have any extras there. Okay, next, go ahead and pause the video because I would like you to draw the Bohr model for a hydrogen atom. And here is what that hydrogen atom should look like. You've got 1 proton in the middle that's shown in red, and then you have 1 electron, which is on the very first ring that is right next to the nucleus there. All right, let's see what you can come up with then. These are the big takeaways that you should remember from today's little lesson. So electrons are shared in 5, 4, 3, 2, 1. Covalent compounds, exactly, covalent. So that prefix co that we have right here, this prefix co means sharing, like co-workers share a place of work, and cooperation means that people are working together. So co means sharing. So that is one way to remember what covalent means. Covalent, sharing valence electrons. Okay, next, how many electrons are represented in each bond line? Now, to answer this, you just have to remember that every atom wants to have a full shell. So how many electrons are represented in each bond line? You just have to look. Your choices are 1 electron, 2 electrons, or 3 electrons. And there we go. Each bond line represents 2 electrons. So if we're looking at the bromine that we have on the left, here it is. It has 1, 2, 3, 4, 5, 6, and then 7, 8 valence electrons, if you're looking at how I'm counting these things. And if we look at our oxygen here, it has 4 dots, and then 2 more electrons in the bond line on the right and 2 more electrons in the bond line on the left. So that also has 8 valence electrons. And then if we take a look at our bromine on the right, it has 6 dots, and then you have 2 electrons represented by the bond line. So this bromine all the way over on the right also has 8 valence electrons. So all of our atoms here have a full valence shell. All right, now you have to circle a lone pair and or an unshared pair of electrons. So circle a single lone pair. And there they are. So it's a lone pair. So a pair means 2. So if you circle the single dots, like if you circled these guys over here instead, then that would be wrong because they are not paired up. They do not have a buddy sitting next to them in your electron dot structure. Okay. Now circle the electron or the electrons that participate in bonding. Those are the unpaired electrons. Those are the singles, the singletons, I like to call them. These are the ones that are really exciting. These are the ones that form bonds so that compounds and other substances can be formed. All right, how many covalent bonds can this oxygen atom make? Well, since we only have 2 unpaired electrons, it can only form 2 covalent bonds. All right, everyone, I hope this was helpful. Enjoy the rest